Suppose Lisa has been able to transfer $25,000 into an RRSP. She plans to let that RRSP accumulate earnings at 4.5% compounded annually for 10 years, and then she's going to purchase a 15-year annuity that makes payments at the end of each quarter. What size of payment can she expect if the funds in the annuity earn 5.25% compounded quarterly? Let's begin by trying to figure out the future value of the RRSP. That is, if we were to input $25,000 today, how much are we going to have at the end of that 10-year period? So what we're going to do is we're going to take our $25,000 and we're going to apply that interest rate of 4.5% compounded annually. Here, since compoundings are happening every year and we're going to have this in our account for 10 years, we know that n is equal to 10. Simplifying this expression gives us $38,824.24. In our next step, let's try to deal with the 15-year annuity and try to determine the equivalent payment size that we should expect. If payments happen at the end of each quarter, and we have a 15-year annuity, let's multiply 15 and 4 together to get n is equal to 60. Next, we know that the interest rate is 5.25%, also compounded quarterly. We're going to input our future value as $0, and our principal amount is going to actually be equal to the amount that we calculated in part 1. And what we're going to do is we're just going to input that as a negative amount because we are going to purchase this 15-year annuity. And the last thing we need to make note of here is that payments do happen at the end of each quarter, so we do need to ensure that our calculator is in end mode. Currently, my calculator is in begin mode, so I'm going to go ahead second PMT. We're going to second set to get back into end mode and then quit that submenu. Now I can go ahead and start programming in my values beginning with n, and then we'll go over to our 5.25. Going into the submenu, we need both PY and CY to be set as 4. We're going to take the number that we calculated in part 1 and ensure that it is a negative value, and input that in for PV. Now we're going to calculate the PMT. I'm going to put 0 in for FV here, and that should allow us to go ahead and compute the payment size. And doing that gives us an equal-sized payment of around $938.98.